In this episode, we shift into a Windows-focused automation mindset. Because enterprise operations rarely live in a single operating system world, and many automation workflows need to behave reliably on Windows the same way they behave reliably elsewhere. PowerShell is a major part of that reality, not because it is trendy, but because it is designed to manage systems through structured commands that return structured objects rather than messy strings. Beginners often approach PowerShell as if it were just another command line with different spelling, and that is where confusion starts, because the real power comes from understanding cmdlets as consistent building blocks and understanding the pipeline as a controlled flow of objects. At enterprise scale, effectiveness is not measured by whether something works on your machine one time, because it is measured by whether it behaves predictably across many endpoints, many environments, and many hands. That predictability depends on knowing how cmdlets express intent, how they return data, how you filter and transform results, and how you handle failure conditions without creating drift or silent errors. The goal here is to build a concept-level understanding of how to use PowerShell cmdlets in a way that aligns with safe automation principles, especially in cloud-connected and security-sensitive environments. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A cmdlet is a single-purpose command designed to perform an action or retrieve information, and the naming convention is part of how PowerShell communicates intent. Cmdlets typically follow a verb-noun format, which helps you understand what they do without memorizing every detail. The more important concept, though, is that cmdlets tend to return objects, not just text, which changes how you should think about automation workflows. With objects, you are not scraping characters. You are selecting properties, filtering by values, and making decisions based on typed fields. That object orientation is a major reducer of silent parsing failures, because your automation is less likely to break due to formatting changes like spacing or punctuation. In enterprise operations, this matters because output can vary across versions, locales, and configurations, and string parsing is brittle across those variations. A beginner might be tempted to convert objects into text early because text looks simple, but that choice often discards type information that protects you from bad comparisons and truthiness mistakes. Effective cmdlet usage keeps data structured as long as possible, then converts only when necessary for output or integration with a non-object consumer. This discipline supports predictable behavior at scale because it reduces the number of places where meaning can be lost. The PowerShell pipeline is another core idea, and it is easiest to understand as a conveyor belt of objects moving from one stage to the next. Each stage either produces objects, filters objects, transforms objects, or performs actions based on objects. Beginners sometimes imagine a pipeline as a string of text being chopped up, but in PowerShell, the pipeline is often a chain of object transformations. That difference is why PowerShell pipelines can be more reliable for automation than pipelines that depend on brittle text matches. When you pass an object along, the next cmdlet can access named properties directly, which is like having labeled fields instead of unstructured paragraphs. At enterprise scale, this label-based access reduces errors when you are selecting targets, checking states, or validating that a control is enabled. The pipeline also encourages composability, meaning you can build larger workflows out of smaller, well-understood pieces, which aligns with the function and encapsulation mindset you learned earlier. Composability reduces operational risk because each piece can be reasoned about in isolation and tested mentally with expected inputs and outputs. Filtering is a major operational skill in PowerShell, and the key is to filter based on meaning, not based on what happens to be printed. With objects, filtering means selecting items whose properties meet certain conditions, such as selecting all resources with a particular state or all accounts with a certain attribute. This is safer than filtering by a text pattern because it is less likely to match the wrong thing accidentally. It also supports deterministic behavior, where the same inputs produce the same outputs, because property comparisons are consistent. Filtering matters in security and cloud contexts because you often need to scope actions to a specific environment group, or compliance state, and poor scoping is a classic cause of automation incidents. A safe approach filters early, which reduces the number of objects that later stages can act on, limiting blast radius if something goes wrong. It also validates that the filter results are what you expected, such as confirming that you selected the right number of targets or that the targets match an expected naming pattern. Effective filtering is not just about speed, it is about safety through controlled scope. Parameters in PowerShell matter for the same reason they mattered earlier in this course. They make intent explicit and reduce hard-coded assumptions. At enterprise scale, you rarely want a script that assumes a fixed environment, fixed paths, or fixed identifiers, because those assumptions break as soon as the script is reused by another team or run in another context. Cmdlets are designed with parameters that let you specify targets, modes, and options, and learning to use those parameters effectively means learning to express what you want clearly. The safety aspect is that good parameter use reduces ambiguity, which reduces the chance of acting on the wrong target or using the wrong default. Defaults can be dangerous when the default is not aligned with enterprise safety expectations, such as a default that uses the current context when you intended a specific context. A disciplined approach is to choose parameters that enforce clarity, to validate parameter values early, and to treat missing or ambiguous parameters as reasons to stop rather than reasons to guess. This is especially important for scripts that can modify security settings or identity controls, because guessing in those domains is not acceptable. Effective Cmdlet usage is not just knowing what parameters exist, it is knowing how to use parameters to reduce operational risk. Error handling is where PowerShell automation can either become enterprise-ready or remain a collection of one-off tricks. Failures occur for many reasons, such as permissions, connectivity, policy restrictions, resource locks, or transient service issues, and the key is to handle failures in a way that is predictable and visible. In object-oriented workflows, errors can show up as error records, exceptions, or status properties, and effective automation designs recognize that not every failure should be treated the same. Some failures are transient and might justify a controlled retry, while others indicate a security boundary or a misconfiguration that should cause an immediate stop. A beginner mistake is to ignore errors and continue, which can create partial changes and drift across systems, leaving the environment inconsistent. Another mistake is to treat every warning as fatal, which can reduce availability by halting workflows unnecessarily. A safer approach is to define what failure looks like for the workflow, to distinguish between recoverable and non-recoverable failures, and to ensure that failure paths leave the environment in a known safe state. On exam questions, the best answer often reflects controlled, visible failure handling rather than optimistic continuation. Idempotence is also critical at scale, because enterprise automation often runs repeatedly, sometimes on schedules, sometimes in response to events, and sometimes as part of pipelines. If a script makes changes every time it runs, even when the environment is already correct, it creates unnecessary churn and increases the chance of introducing side effects. Cmdlets that query state and cmdlets that set state can be combined in a way that checks current state before applying a change, which supports idempotent behavior. This is safer because repeated runs converge on a stable target state rather than oscillating or drifting. In cloud-connected Windows operations, idempotence helps when endpoints are not always reachable, because the automation can safely run again later without doing harm. It also helps with compliance-driven controls where you want to enforce a desired configuration consistently over time. Beginners sometimes write scripts that assume the world is always in the same starting state, but at scale, starting states vary, and a robust script must handle that variability gracefully. Effective Cmdlet usage includes designing workflows that can be rerun safely, which reduces incident risk and reduces the need for manual cleanup. Enterprise scale also introduces concurrency and distribution concerns, meaning automation is often applied to many systems and must cope with partial availability. A workflow might process hundreds of endpoints where some are online and some are not, or where some have different configurations due to staging, patch levels, or policy rollouts. In those conditions, the safest approach is to design for partial success intentionally, deciding whether to continue when some targets fail or to stop when failures indicate a broader problem. This decision should be based on risk and on the type of action being performed, because continuing might be acceptable for observation but risky for state changes. PowerShell workflows often process collections of objects, which aligns naturally with this design, but the operator mindset must be deliberate about how failures are recorded and surfaced. If failures are swallowed, the automation produces a false sense of completion, which is a silent failure at the workflow level. If failures are captured with enough context, teams can remediate intentionally and rerun safely. Exam questions in this area often test whether you will build automation that scales responsibly rather than automation that assumes perfect conditions. Integration workflows are another reason PowerShell matters, because Windows automation is often part of larger pipelines that include cloud services, identity systems, and monitoring platforms. When data crosses boundaries, type discipline becomes important again, because some stages speak in objects while others speak in text, and losing type information can create logic bugs. Effective cmdlet usage means being aware of when you are working with objects and when you are working with strings, and ensuring that conversions are deliberate and validated. It also means producing outputs that are predictable for downstream consumers, whether that means structured outputs or stable text summaries that can be parsed safely. In security contexts, integration often involves policy enforcement, logging, and response actions, which means the consequences of misparsing are higher. A disciplined approach preserves structure when possible, validates at boundaries, and fails safe when the data is incomplete or ambiguous. This approach aligns with the earlier episodes on JSON and validation, because the same principles apply even when the tools differ. Reliability comes from consistent design habits, not from a single platform. Security is woven through enterprise Windows automation, even when the task seems purely operational, because automation often runs with elevated privileges or touches sensitive settings. Effective use of cmdlets includes understanding that your automation can become a powerful actor in the environment, which means it must be constrained through safe scoping, careful parameterization, and conservative default behavior. If a script can change access settings, the safest design requires explicit targeting and explicit confirmation conditions, not implicit assumptions. If a script reads sensitive information, the safest design avoids unnecessary logging or output that could expose secrets. If a script interacts with identity and access control, the safest design treats permission errors as serious signals rather than as minor inconveniences to be bypassed. This is not about making automation slow. It is about making automation trustworthy. Trustworthy automation is what enterprises adopt, because enterprises cannot afford tools that work only when the author is watching. On exam day, answers that reflect least privilege, explicit targeting, and visible validation often align with best practices and with the intent of the certification. Another common beginner misunderstanding is confusing cmdlet effectiveness with sheer brevity, as if the best solution is the one with the fewest characters. In enterprise operations, the best solution is the one that is understandable, maintainable, and safe under change. That usually means clear parameter use, explicit filtering, and deliberate handling of errors and edge cases. A short pipeline that does too much implicitly can be fragile and difficult to troubleshoot, while a slightly more explicit workflow can be far safer. This is similar to the function encapsulation lesson, where clarity reduces risk by reducing the chance of unintended interactions. Effective automation also means thinking about who will read and run the script later, because enterprise automation is rarely a solo artifact. Scripts become shared tools, and shared tools must be clear and predictable. When you optimize for clarity, you reduce the chance that someone misuses a script under pressure and causes an incident. Clarity is a security control when it prevents human error. As we bring this together, the main idea is that using PowerShell Cmdlets effectively at enterprise scale is about designing object-based, parameter-driven workflows that are safe by default and predictable under imperfect conditions. When you treat cmdlets as composable building blocks, preserve structure through the pipeline, and filter by properties rather than by brittle text patterns, you reduce silent parsing failures and improve determinism. When you validate inputs, handle errors deliberately, and design for idempotence, you reduce drift and make repeated runs safe, which is essential for large environments. When you think about distribution, partial availability, and integration boundaries, You build workflows that behave responsibly rather than optimistically. And when you keep security considerations front and center, you ensure that automation remains a force multiplier for control rather than a force multiplier for risk. On exam day, the strongest answers in this domain usually reflect explicit intent, conservative defaults, and visible validation, because those are the qualities enterprises need from automation. If you adopt that mindset, you will be able to use PowerShell confidently not because it is easy, but because you will be building workflows that are designed to scale safely.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.